Okay, class, today we begin Unit 2, Triangle Basics. We're going to be looking at triangles, and obviously with triangles we're going to have angles, which we studied a little bit in Unit 1. Okay, different ways you can name triangles. One way is called equilateral, which means all three sides are congruent. If I drew a triangle, I would do 1, 2, 3 sides, and I put little tick marks on all three sides to show that they are congruent. Another way is called isosceles, which means two sides are congruent. I draw a triangle like this, and I put tick marks on here to show those two sides are congruent. And scalene is no sides are congruent. Maybe something like this. I don't know, something like that. Another way is by the angles. Acute triangle is all three angles are acute. And acute means less than 90 degrees. The second way is obtuse. That means I have one obtuse angle, and obtuse means greater than 90 degrees. And then finally a right triangle, which means I have one right angle in the triangle. That means it has to equal 90 degrees. And for both these obtuse and right triangles, I would have to have two acute angles. So an obtuse triangle has one obtuse, two acute, and a right triangle has one right and two acute. And a right angle, if I ever drew a right angle, I always draw a right triangle like this. Put the little perpendicular right angle in there. So let's classify these by its sides. Well, 4, 4, 4 means they're all congruent. Means equilateral. 6 and 6, that means two of them are isosceles. 5, 7, 10, none of them are scalene. And this picture has no numbers on it, but these tick marks here represent that these are congruent sides. Again, isosceles. Now we could classify by their angles. Well, I see this little square, so this is a right triangle. All three of these are less than 90. So this is an acute triangle. This one's bigger than 90. This is obtuse. And all three of these are less than 90, so this one is also acute. And if you notice they're all equal, it would be an equilateral. Because if all three angles are the same, then all three sides are the same. In geometry, we use ideas called theorems. They're called theorems because we could prove them. As opposed to that postulate that we did before, where that's something we can't prove, we just accept. So this theorem that I'm going to show you in a second is called the triangle sum theorem. And many of you already know that the sum of the angles add up to 180. So the sum of the interior angles of a triangle equal 180 degrees. This is nothing new to you guys most likely. And I'm going to talk about this triangle below. I'm going to prove it by doing parallel lines. So this triangle below I call triangle, and I do it A, B, C, because I name it by each vertex, or the plural vertex is vertices. And now we're going to do a proof using parallel lines. Many times when we do proofs, we do something called statement reason. The statement is something we say, and then we give a logical geometric reason why it is true. So I labeled all my angles here, 1, 2, 3, 4, 5, 6, and I know that angle 1 is congruent to angle 5, and probably angle 3 is congruent to angle 6, and I use one arc for 1 and 5, and double arcs on 3 and 6. So my first statement is angle 1 is congruent to angle 5, and angle 3 is congruent to angle 6. And the reason I know this is alternate interior angles are what I call AIA for short. The second thing I know, I'm going to use a different color, is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees, because, and the reason angle 1 plus angle 2 plus angle 3 equal 180, because they form a straight angle. If you notice right here, they form the line, and it's a straight angle. And then finally, another thing I can do, well, 1 is 5 and 3 is 6, so the measure of angle 5 plus the measure of angle 2 plus the measure of angle 6 is equal to 180 degrees. I could do that based on substitution. And the idea is that 1 is being replaced by 5 and 3 is being replaced by 6, because we said they were congruent, and there's my proof based on congruence. This page has an activity that you could do with a piece of paper to fold along to show that it is equal to 180 degrees. We're not going to have time to do that in class, but let's go to a picture and let's see what we can figure out what all these angles are. So I'm going to draw all the angles on this picture first, and then I'll go back and answer all these angles. I know the right angles here are both 90. I know that the measure of angle 4 plus 40 plus 20 has to equal 180 because they're a triangle. So therefore, I get the measure of angle 4 is equal to 120 degrees. And then I know that the measure of angle 2 also has to be 120 degrees because they're vertical angles. The next thing I know is that the measure of angle 3 and the measure of angle 4, 120 degrees, have to add up to 180 because they're a linear pair. So the measure of angle 3 is 60 degrees, which means the measure of angle 1 is also 60 degrees. They go together. Well, then I have two triangles. I have this little triangle here and this big triangle here, and measure of angle 6 plus 60 plus 90 equal 180, and the measure of angle 5 plus 60 plus 90 is also 180. So angle 6 is 30 degrees, and angle 5 is also 30 degrees. So angle 5 and angle 6 are congruent. If I fill in this picture, I get 60 degrees, 60 degrees, 30 degrees, 120 degrees, 120 degrees, and this last one is 30 degrees. So the next theorem we have is called the exterior angle theorem, and an exterior angle is the angle on the outside of the triangle from the extended line of a side. So here's side AB, here's line AB extended out, and this red angle is the exterior angle. The exterior angle theorem states that the measure of this exterior angle 4 is equal to the sum of the two non-adjacent interior angles. So angle 3 is the adjacent angle. The two non-adjacent angles would be the measure of angle 1 plus the measure of angle 2. This is the adjacent angle. So angle 4 is going to equal the sum of angle 1 and angle 2, and now we're going to prove it. Well, right now I wrote out a couple of statements and reasons, and the idea is that the one in pink is angle 1, 2, and 3 are the triangle. They add up to 180. The one in red, angle 3 and 4 are linear pair. They add up to 180. Therefore, they both equal 180. So measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4. And that's just a substitution trick. But then I see that these two guys can cancel out. And then my last statement is the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4, because I subtract out angle 3. So that's just by subtraction. And there we go for that proof. So let's try some example. Here's my exterior angle. Here are my two interior angles. Y equals 42 plus 20. Y equals 62 degrees. That was way too easy. Here is my exterior angle. Here are my two interior angles. So 4x plus 8 equals 2x plus 3 plus 51. 4x plus 8 equals 2x plus 54. Subtract the 2x, subtract the 8, subtract the 2x, subtract the 8. 2x equals 46. X equals 23. Okay, the triangle inequality theorem talks about that not any three sides could be a triangle. You have to have certain things that happen, and that the sum of any two sides must be greater than the third side. Here's a triangle with three sides, side A, side B, side C. So A plus B always must be greater than C. B plus C must be greater than A, and A plus C must be greater than B. That has to always happen. So for an example, I have sides 3, 5, and 10. So let's say this bottom side is 10, this little side is 3, this other side is 5. Okay? They would never meet up here to make a triangle. Okay? Side 3 and side 5 are too short to cover this gap, this side 10, and they would never form. And I'm just going to take the two shorter sides. 3 plus 5 is not greater than 10. So it's never going to be a triangle. Same thing here. Here's side 8, here's side 3, here's side 5, and they would meet, but they would lie flat on top of the 8. So again, it would not be a triangle. 3 would lie flat, and 5 would lie flat, and they would barely touch. And again, I can show that 3 plus 5 is not greater than 8. It equals 8, so it's not a triangle. And then finally, this last one, I have this side is 6, this side is 3, this side is 5, and 3 plus 5 is greater than 6. So, yes, I finally have a triangle. So when I do the triangle inequality theorem, I always take the two shorter sides and see if their sum is greater than the third side. Let's try some examples. So on this page, I took the two shorter sides, and I see that the sum of the two shorter sides is greater than that third side. It's a triangle. On problem number 14, it didn't work out. 11 plus 16 is 27. It's not going to be greater than 32. They'll never meet. So what could I have? So I give you two sides. What are my possible lengths I could have? Well, what I could have is what I could do is, let's do the sum, which is 18. Let's do the difference, which is 6. So my value for this missing side has to be between these two sides. Any value erase this. any value in between 6 and 18 would work. So I could have x equals 8, x equals 15. That could be the third side of that triangle. I'll do the same thing here. Well, my sum is 11. My difference is equal to 5. So any number between 11 and 5, 11 and 5, yeah, any number between 5 and 11 will work. An example is x equals 10. Anything below 5 or anything greater than 11 would not work. So angles and sides of a triangle go hand in hand. The shorter the side, the smaller the angle. The longer the side, the larger the angle. So whatever is the longest side of a triangle, across from it or opposite it is the largest angle. And the shorter side across from it is the smallest angle. I'm going to draw a picture below to demonstrate it. Okay, here's a general triangle. I think it's scalene. All sides are not the same. I use capital letters for the vertices, the points. I use lowercase letters for the sides. So this is definitely the smallest side. Side A is the shortest side. And that means angle A here is the smallest angle. Side B is the next shorter side. And that means angle B is the angle in the middle. And then we have side C, which is the longest side. And then the angle C is the largest angle. If you look carefully, that should work. But that's the way they work. They go together. Shortest side, smallest angle. Longest side, largest angle. Looking at the triangle in number 1, 6 is the shortest side, and across from it, or opposite of it, is angle C, which is the smallest angle. And obviously 18 is the longest side, and across from it, go right across the middle of the triangle, this is the largest angle. Over here, 10 is the longest side, and across from it, going right through the middle of the triangle, angle Q is the largest angle, and side 6 is the shorter side, and across from it is angle R, which is the smallest angle. And then these last two, if you notice, I have 50 is the smallest angle, so across from it is the shortest side, and that was side RT. And then across from the 70-degree angle is side ST, which is the longest side. This one over here, I had to figure out this last angle. Well, I have 90 degrees here because of the perpendicular, the right angle symbol. That means 55 degrees is left over. And 90 degrees across from it is the longest side, and across from the 35 degrees is the shortest side, KJ. And here's the idea. The opposite side from a right angle or obtuse angle will always be the longest side. Always. A right angle will always be the largest angle in a triangle, and an obtuse angle will always be the largest angle in a triangle. Therefore, across from it will always be the longest side. Okay, thank you for watching my video.